Hey everyone, in this video we are going to break down a really interesting problem. So this is a daily challenge and we will going to solve this problem. So I will explain each and every line of code. By the end of it you are not able to just memorize it and you will actually understand how it works. So yeah, so let's go through the problem statement. So this problem is minimum operation to convert all elements to zero, right? So this, let's go through the description of the problem. So you are given an array of that is called as num. So this is an array that is given. So here we are representing array in the form of vector. So as we are here, so just basics is we all know that array is a continuous continuous yes allocation of memory of any data type, right? It can be number, it can be a character and so on. So arrays will be like in this form: 1, 2, 3 and so on. And it can be a character like C, D, E, right? And it can be also array of string. It can be any data type. So array is a continuous allocation of memory of any data type. So right, we are given an array of size n. So given array of size n and it consists of non-negative integers. So there is an array of non-negative integers. So all the integers present in that are positive, right? So what is our task? Our task is to apply some operations on the array. So we have to apply some operations. It can be possibly zero, so that all the elements become zero, right? So what we have to do, yeah, we will go through that board also. So what one operation do, right? So in one operation you can select any sub array is a smaller part of the array. So what is sub array? We select an I, we select a j. For example, we select so what we say, this is index, this is 0 index, 1, 2, 3, right? So in array we start from 0. So 0, 1, 2, 3. So we select an I that let's say, and we select a j. So this will become a sub array. Sub array is a smaller part of the array, right? So this is a sub array, right? This is also a sub array of an array, right? So the array is a sub array is a smaller part of the array, right? If you go through the link, you can also know about sub array is a continuous sequence of element within an array, right? So that is a smaller part. So now we can select an subarray, right? And select all occurrence of the minimum non-negative integers and make it zero, right? So for example, if we are saying here it is 1, so if we are selecting 231, so the minimum non-negative integer here is 1. So right, so we will make it 0. So just like that, we have to select a sub array here. If we are selecting the whole array, then the minimum one is 1. So we will make it 0 like this, right? So this is the problem statement. At one operation, we will mark it at 0 in any sub array, the minimum non-negative integer, right? And we have to return a minimum number of operations that is required to make all the element of the array 0, right? So did you understand the problem? Yeah. uh, yeah, so let's move forward with some examples, right? So let's say we have an array 0 and 2, right? So what we can select is let's say this. So this is the 0th index, this is the first index, ठीक है? So if we are taking this as an sub array, so what is the smallest non-negative integer here is 0. right? So we will mark it as 0, so it will become 0. So there is no change in the array if we are selecting this sub array, right? So now let's uh, take another example, another sub array. So if we are taking this as a sub array, right, this is also a sub array. So if we are taking this as a sub array, in this sub array the smallest value is 2, so we can perform this operation and make it 0, right? So the array will become like this. Array will become like this after performing one operation, right? After performing one operation, yeah, we can say like this, right? So we are performing one operation and this will become 0. Now let's take another example. Here this is 0 2, and now let's take this example 3 1 2 1. So let's take this example. This is 3 3 1 2 1, right? So let's say if you are taking this as a subarray, this as a subarray. So now the smallest possible value, non-negative value is 1. So it will become like this: 3 1 2 0, right? We have chosen one subarray and mark it as 0. But we can say uh, in one operation we can say we can mark two zeros, for example. Let's say, let me remove this, right? So let's say if we are taking this as a sub array, right? So here we can this is the smallest one, this is the smallest one, we can make it 0. So it will become like this: 3 0 2 0, right? Now we can take this now as an sub array, right? So it will become 0, and after that we will take this as a sub array, it will become 0. So we will got 1 from here and 2 from here, right? So this total sum as this total is as 3, right? So yeah. So did you get it? Like how we are choosing as we are choosing any sub array and we are marking it as 0 with the minimum non-negative integer marking it as 0, and after that we are adding the number of possible operations we need to perform, and we have to minimize this operation, right? We can say let's say example, we can say uh, 3 1 2 1. We can say we can first take this sub array, right, and mark this as 0, right? And after that we can take this sub array, mark this as 0, right? After that we can take this sub array, mark this as 0, right? And after that we can take this sub array and mark this as 0, right? So this is like 1 2 3 4. So total 4 operations. So this is more and than this. So this is the optimized answer for this, right? So let's take in another example. That is 1 2 1 2 1 2, right? Let's take this example: 1 2 1 2 1 2, right? So now how we can solve this problem. Let's say at one go we can either remove 2 or 1 uh, as a collectively taking the sub array. So right, so we can take this, let's say 2. So here whole 2 got covered, so we are taking the maximum number, which maximum number of occurrence which are present, and taking that, right? So we are taking like 0, right? Yeah, marking it. Oh, this. So here, let's take this example, and now here we can say the smallest number is 1, and which can be optimized, which can make 0 at once. So we are taking this as a sub array, marking it as 0, right? This marked as 0, this marked as 0. So here we can say, so now moving forward, this is the one step, right? So now we cannot take this as a whole subarray, because subarray should be continuous, and here if we are taking this continuous subarray, this 0 is the smallest possible value, so this subarray did not get changed in any operation, so we have to exclude this 0. So that's why we have to take this separate subarray, right? So we will make it as 0. Now we will take this, then we will take it as 0. Now we will take this, we will take this as 0. So yeah, so here we can say 1, 2, 3, and 4. There are 4 possible ways, like 4 operations are required to perform this operation, right? To make the array as 0, right? So now, what is the intuition behind it, how we will think, what we should use and what we should not? So here, in this thing, we have seen a pattern, like either it should be in increasing order, for example the sub array should be in increasing order, or either in decreasing order, right? If we are taking 1, 2, 1, right? And let's say 1, 2, 1, 2. Let me remove this. Let me say 1, 2, 1, 2. So either this, let's say this should be covered as 1, like for example if we mark the smallest one as 0, and this one should also consider as 0. So this two get resolved separately, because we cannot resolve it as once, because there is a smaller number which is already existing in this, and which makes the array unchangeable, or we cannot change the array, so we have to treat this array and this array separately. So so that's why I say either it should be in increasing order or decreasing order. So let's say it should be in increasing order, so that we can um, handle it separately, right? So for this type of questions, we use stack to solve the increasing and decreasing type patterns. So how we will solve this problem? Using stack. So we are going to use stack for this problem, right? So now let's take the example of 1, 2, and 2. So 1, 2, 1, 2, 1, and 2, right? So we will take a stack here. Let's say there is a stack, right? So whenever there is an empty stack, we will go through from this end, right? And we will put one here. Let me zoom in out. So we will put one here, right? So we have to maintain a increasing order. We have to maintain an increasing order. So we will check, we will take 2, and 2 is bigger than this, so we are maintaining the increasing order, right? So we will put 2 here, right? So now we will check, we will go by 1. So 1 is smaller than this, right? So we will remove this 2, right? And we have to maintain a counter. Okay, we will maintain a count. Yeah. So our count is currently, so we have removed 2 from the stack, so we will increase the count by 1. So currently it's 1, and we will remove the elements until we will reach either the same number or the smaller number. So we will put 1 here, right? So we will again tackle 2. So this is an increasing order. We will go forward with this, right? So again we tackle 1. So we will remove this 2 from the stack, we could, because it is smaller. So we will increase the count also, right? So we will increase the count to 2, and put 1 here, right? So now here we will insert 2. So this is the increasing order. Now we have traversed the array, right? We have traversed the array. So now we will check how many distinguished elements numbers are there in the sub array, like array, because they are all to mark it 0. We need a sub array for this. So this will count as 1. This will count as 1, right? We just need to make it distinguish. So we will, there is two different type of array. We will plus 2, we will add into that, right? So it will become 4, right? So this is how we use stack, and in maintaining the increasing order, we can solve this problem, right? If we want to take another example of this, let's say we have 0 and 2 in the example. So what we can say, we are maintaining a stack, so we will cut as 0 in this, right? So here this is an edge case, that's why I am taking this example. So right, so here we are pushing 0 here, right? And if this is 2, we are pushing 2 here. So if now the array got completed, now we have to check, like, if like this is a distinguished number, this is a distinguished number, but we cannot count 0 as a distinguished element, because 0 is already at a 0 state, and we have to make an element to element 0 in the question. So that's why we are not counting this. So this answer will get 1. So we have to make a check, like whenever we encounter 0, we should not increase the counter, right? So let's go to the coding part. So yeah, let's coming to the coding part. So let's say I am going to code in C++, right? So I will explain each and every line of code here. So we what I have done is, I am taking the size of the array that is given to me, right? So I have taken the size of the array. Now moving forward, if we will provide some base case. What is the base case? Base case is the end case where we encounter some edge cases, like if the array is empty, then we do not require any operation. So we can say, if n is 0, that is the array is empty, then we just need to return 0, because there is no operation is required, right? We will create a stack here, right? So stack is of type integer, right? Stack is of type integer, and now we will take how many operations that are required, that will make 0, right? So I am looping over the array once, right? This integer, this I, is denoted as index, which tell us at which index we are on for now on in the array, right? So now we will make some conditions here. For example, if the stack is empty, we will just push the number into the array, right? Now moving forward, and we can say otherwise what we should do, either if or else. This is a very uh, general problem, right? General problem we can say, or something like that. So what we will do is, we will say what is the last popped element. Okay, last popped element in the, so let's say we are taking it at -1 because with all the all the elements are numbers are non-negative, that's why I have taken it at -1. So what we will do, uh, if while dot empty and st, and we can say should be st cut off, right? So what we are doing, we are looping over the elements of the stack and just searching the top element should be uh, less than the number, indexed number which we are on. Otherwise we have to pop it out from the stack, right? Where we have seen, right, whenever we are reaching 1 or 2, and whenever we are reaching 1 again, then we have to pop out 2. That's what we are doing. So what we will do here, now we will perform some action. So we will take out the top element. If the value is smaller than the top element, then we will take out the top element, and right, and we have taken out the top element. So we will check if the top element should be not equal to 0, right? We are making a condition here, and what should be the other condition? That condition should be like, the tab value should not equal to the last popped element, because we are considering all the element as an array. So whenever we making an element in a sub array is 0, so in all the element which are all the same are become 0 in one operation. That's why we are considering the last popped element should not be equal to uh, the the current element. If they are equal, then we have to skip the count, that is operation. So if they are unequal, then we just operations, we are increasing operation and we are tracking the last popped element should be the top value. The value should be different, right? Now after that, when we done this, we will push the element to the array. So right, so what we also do, we can also do this like this, in the, we can take it out as a common, because this is a, right, this is a common statement, and we can also optimize it like this, like if the array is not empty, then perform this, right? We can remove this else condition. This is just an optimized version. I am just making the code clean. So when we get to the end, then we have to check how many distinguished elements should be there. So we can say uh, last popped should be -1. So here we have taken, we are created two same array, so uh, we can create it here, right? So we just initialize here so that we do not create again and again, right? So we can say while this this stack will be empty, right? So in top val should be st cutoff, right? And st dot pop if the top value if the top value, no, we can say if the top value is not equal to 0, the same condition, and the top value is not equal to the last popped element, right? So we can say we can increase the operation part. This thing will be the same, we can say, right? And at the end we just need to return the operation. So now let's make a dry run for this, right? Let's make a dry run. How will you explain this to an interviewer? For example, let's take an array 1 2 and 2 1 2 and let's say 1, right? So we will add the index this 1, so it will go there, and the stack is empty, right? Let's say this is our stack, right? So we can say stack is empty, so stack is empty, so we will just push the code here, right? It will insert it as 1. Now we will iterate to second element. So second element, now the stack is not empty, we will check the number, that is the 2 is smaller than the top of the element. No, it is bigger, so we will just insert it. This condition will become false, it is take get outed, and we will just push it. Now it 1 came at the, in this case the this conditions becomes true, right? And we will take out the top element, we are taking 2 from the bar, and we can say this top value will become 2, and last popped value is -1. So now that it is 2, so we can say this is not 0, right? And this is not equal, so we can say the operation will become 1, and operation will become 1, and last pop element will become 2, right? And we insert 1, we insert 1 in the we insert 1, let's say इसको ऐसे कर देते हैं, we insert 1 in the in our stack, right? And now we will iterate further. We will check, there is 2, which this condition will become false. 9, we are inserting 2 here, right? Again 1 came, and when 1 came, so we can say this condition will become true. We will take the top element, that is 2, and we will take the last popped element, that is -1 for now. Like in this condition it will come a -1, right? And this is not equal, so we can say this will become this will get outed, and this will become this, right? So we will again insert 2 from here, because this condition will become false. Now 1 came, and we can say 1 is here, and the top will become 3, because we have popped out this and this, right? So this will become 3 now. So now all the array got completed, and we are here with the 4 ones, right? So we are here with the 4 ones. So the this loop get completed, and now we are here. So last popped element is -1. We can take this, right? Now in our stack, this is the thing. So now we will take the top value, that is 1, right? We will make we will mark it as 1, right? And we will make the operation plus plus, that will become 4, and now we will make the last element as 1. Now we will again pop up the element, and the top element become 1. Now that these both are similar, so we will not make the operation like make again open make the operation, so it will go further, and this will get empty, and when it get empty we will return the operation that will become the 4, right? So this is how we solve this problem, and let's run this now. So there is an mistake like this. Let's run it again. There is another miss also. Let's run it. That is a silly mistake we have done. Right. So it is now. Let's submit this code. It got submitted. Right. So yeah. So thank you for watching this tutorial. So yeah. I will get back with some more videos on this, and thank you for watching.